Greetings to all the viewers. The session is going to cover the international chemistry on the international entrance and competitive examination floor. India is conducting JEE Advanced, JEE Mains examination all across India twice a year to get the admission into IIT and NIT stream. Medical entrance will be conducted by NEET examination across India, and Telangana, Andhra Pradesh government are conducting MSET examination to get the admission into the BTech stream. Government organizations are conducting various competitive examinations. Their general studies question paper will be there. General science content, whatever available, is very much fetching for that kind of preparation as well. Let's go with the question number 1. The Royal Swedish Academy of the Sciences has decided to award 1989 Nobel Prize in the Chemistry jointly to Sydney Altman, Yale University, New Haven, Connecticut, USA, Professor Thomas Keck, University of Colorado, Boulder, United States of America. These two eminent scientists together gone with the discovery of catalytic properties of ribonucleic acid. And let's see how the research exploration got carried by these two eminent scientists and how they got accorded with the world recognition called Nobel Prize for the year 1989. This year's Nobel Prize in the Chemistry has been awarded to Sydney Altman, United States of America, Thomas Keck, USA, for their discovery RNA ribonucleic acid in living cells do not only a molecule of heredity, but also can function as a biocatalyst. They are working like a catalyst. A new perception RNA is working like a biocatalyst. That new perception got established by these two scientists together. This discovery, which came as a complete surprise to the scientists, concerned fundamental aspects of the molecular basis of the life. Whatever they invented, they established that entirely changed the perception about the living organism, their metabolic activities. Many chapters in our textbook have to be revised because of this kind of new, that is a kind of authentic information which is acceptable and applicable. That's the reason why whatever already traditional perceptions are there, they're to be modified. Many chemical reactions cannot occur without the catalyst. Catalyst is the component which will accelerate the rate of reaction. Catalyst is a molecule which can facilitate chemical reaction without being consumed or changed. Visually, all chemical reactions are taking place in the living organisms by the process called catalysis. And enzymes are also called biocatalyst, and example, saliva. In our saliva, we have a certain enzymes which used to convert the complicated carbohydrate called a starch into a simple hydrocarbon called a glucose. In the liver, there will be a kind of another enzyme you can notice which used to break down the alcohol. There are also enzymes that enables plants to convert carbon dioxide into the sugars and starch. Carbohydrates will be generated by photosynthesis. Until the result of Altman and Keck become known, all enzymes were considered to be proteins. Earlier, there is a misconception regarding the enzymes. They are also the only the considered as proteins, but exceptionally they have the acceleration of the reaction. Hence, they together regarded as a new name called enzymes, which are biocatalysts. The specific properties and functions of proteins are determined. Hereditary characters are genes. Genes are composed by deoxyribonucleic acid, better known as DNA. Right. So here DNA is a hereditary factor which is composed by the deoxyribonucleic acid, and the genetic information in the DNA is arranged in the string of codes. Certain triplet codes are available. Because of that arrangement, only whatever characteristics we have which can be governed, which determines the design of the proteins. Right. So protein synthesis is carried according to the arrangement of these codons on this DNA. However, before this information can be used for the protein synthesis, code must be transcribed. So in order to synthesize a new protein, so the transcription of the information should be done, and that will be turned into a other kind of nucleic acid, and RNA will be synthesized in turn. Altman and Keck have now independently discovered RNA is not only a molecule hereditary, but can also serve as a biocatalyst that not taken as such from the forefathers. Rather, it also having acceleration of biological metabolic activities. So we can term it as a biocatalyst. In addition to this conceptual influence on basic natural sciences, the discovery of catalytic DNA will probably provide a new tool for the gene technology. Right. So here the property of catalytic activity now in turn established a new field called gene technology, so that multi-dimensional applications we can notice by means of catalytic activity of RNA, with the potential to create a new defense against viral infections. This catalytic DNA, in order to work in such a manner that used to provide a new defensive system within the organisms, which used to fight against the viral infections. This is the way live driving activity got established by the scientists Sidney Altman and Thomas Keck, so that they are recorded with the Nobel Prize for the year 1989 in the field of chemistry. So by this, we are supposed to conclude the question 1 and entered into question 2, collected from Cambridge International Assessment. Zinc chloride reacted with water, and a solution is acidic in nature. So whenever zinc chloride is added with water, so that equation is possible and giving rise to the zinc hydroxide and hydrochloric acid. Zinc hydroxide itself is indicated as a base. Hydrochloric acid is acidic, but still entire solution is regarded as acidic. Why? Because everybody aware zinc hydroxide is amphoteric in nature, slightly acidic, slightly basic, both the properties are recorded. And hydrochloric acid, being it is a mineral acid, highest acidity we can accord. That's the reason why ultimately the entire solution is regarded as acidic in nature. State the meaning of the symbol double-headed arrow. Double-headed arrow indicates what equilibrium reaction, where a forward-headed arrow indicates the reaction is moving towards product starting from the reactant. The reverse-headed arrow indicates products are converting back into the reactant species. So some kind of reactions are spontaneous, forward, backward are possible within themselves, which are called spontaneous. So that reversible reactions, when mentioned with the double-headed arrow, that is said to be equilibrium. Forward reaction, where left to right-headed arrow, we can notice that reactant to product formation is possible. Whereas reversible reaction, you can notice right to left-hand side, where products get back into the reactant side. This is the way we can indicate, we can make the definition for this double-headed arrow. Go with the pH value of acidic solution. pH is measured on the Sorensen pH scale, where it is ranging from the 0 to 14. The values are laying, and that used to specifically indicate the nature of substance, whatever we are choosing for. And pH laying in between 0 to 6 are regarded as acids which are soaring in nature. And at the 7, that is neither acidic nor basic, so that we can consider them as neutral. And beyond 7, if you are forwarding towards 14, that basic strength gradually increases. This is the way Sorensen pH scale is measured. Negative log of H plus ion concentration is called pH. And the pH value laying at 3 is only considered as acidic, so that we encircled this pH 3. 7 is neutral, 9 is mild base, and 14 is strong base. This is the way we can conclude all the questions which were posed here for question 2. Go with the question number 3. This is collected from JEE Advanced 2014 paper 1 question paper and conducted by the National Testing Agency. The correct statements for the orthoboric acid is are. Orthoboric acid stands for H3BO3. It behaves like a weak acid in water due to self-ionization. So whenever boric acid was taken under acidic condition, it will not ionize itself. Rather, aquated conditions giving rise to the ionized form. So that self-ionization might not be possible. We can strike off this option A. Go with the B. Acidity of its aqueous solution increases upon addition of ethylene glycol. This is the correct one. Ethylene glycol are polyhydroxy compounds are the substances which able to form the annular rings with the what we can say boric acid, so that BOH taken for negative anion will bind chelated with that hydroxy compounds, and subsequently release of H plus is possible. Whenever H plus got released, we can rise the acidity of the substance. So whatever they mentioned in the option B will be the correct only. Correct statements to be taken as the right answers. So we can put a tick mark for option B. Go with the option C. It has a three-dimensional structure due to hydrogen bonding. Boric acid is crystallizing in a layered structure, just like a graphite, right? So three-dimensional structure might not be possible, rather it is the layered structure. But the thing is, though layers are present, all are bounded with hydrogen bonding. Certain extent, the option C will be the correct only, but the three-dimensionality will not be there, rather it is the planarity. So we can strike off option C. Go with the option D. It is a weak electrolyte in water. Electrolytic nature is purely dependent upon the extent of ionization. Maximum ionization is a strong electrolyte. No ionization is the non-electrolyte. Partial ionization is the weak electrolyte. Go with H3BO3. Upon addition of water, a certain extent of ionization you can notice, so that it is the weak electrolyte. Weak electrolyte and pKa values are extremely larger, 9.25. So that weak electrolyte in water is the correct answer only. You can put the tick mark. B, D are the correct answer for question number 3. So this is the way we can answer. Are the boric acid is, it is the question given from inorganic chemistry and a group of 13th elements. Go with the question number 4, collected from the 2014 JEE Advanced. Question paper 1, conducted by the National Testing Agency. The question collected from the total number of the stable conformers with non-zero dipole moment for the following compound is are. How many are possible non-zero dipole moments? We have to calculate. For that purpose, conformational isomerism. Isomerism is nothing but whenever compound is having same number of atoms, but either by the structure or else arrangement of the atoms. If that kind of rearrangement or different compositions are possible, we can say those are called isomers. And isomers are of different kind. Structural isomerism will be there, and next is stereoisomerism will be there. If the orientation varies, that is the kind called stereoisomerism. Stereoisomerism gone through the optical and conformational. Conformational isomerism denotes what? Whenever carbon-carbon single bonds are present, so that by the rotation, if you are obtaining various kind of arrangements, difference in their arrangement, that are regarded as the conformational isomers, and which are having non-zero dipole moment. The condition for non-zero dipole moment is non-symmetric in nature. That means symmetry elements must be absent. Symmetry elements indicate sigma symmetry, identical axis of symmetry, so inversion center, so many will be there, right? So here we will consider about the what we can notice here, sigma symmetry we are taking into the consideration. So here they're asking for the stable conformers to be depicted. For that reason, the Fisher projection can be transformed into ball and stick model, where we are writing the staggered form. Staggered form is regarded as the most stable, and dihedral angle is the equispaced with a 60 degrees angle, so that repulsive forces got minimized whenever. These three are the possible transformers if observed, which are having no symmetry elements in that. If you put a diagonal plane over there, vertical plane over there, horizontal plane over there, we are not supposed to get identical to equal halves. That's the reason why these three, where you can notice bromo-bromo under Gashi conditions, 2-chloro under anti-conditions, and methyl-methyl Gashi conditions. So this is a possibility where we are not having two identical halves by means of any kind of plane, so that this is the compound with non-zero dipole moment. Same will be applicable to second compound also. So there also you can't find any axis of any plane of symmetry over there, so that non-zero dipole is accorded for image number 3 as well. And go with the image number 4, where again you can notice the molecule where symmetry, plane of symmetry is absent once again, so that mu is indicated with non-zero value. This is the way option 1, 2, and 3 are regarded as non-zero dipole moment with the stable conformations. The expected answer will be 3, right? So this is the way question 4 is concluded based on the conformational isomerism for the carbon compounds. Entered into the question number 5, where 2019 IMSET exam conducted was taken into the consideration. What is the solubility product of the calcium phosphate in the pure water? S denotes molar solubility. Shuddha నీటిలో calcium phosphate ద్రావణీయత లబ్ధం ఎంత? S molar ద్రావణీయత, right? So calcium phosphate, if taken into the consideration, solubility product to be identified. First of all, we have to know what is meant by solubility product. Calcium phosphate upon ionization giving rise to the 3 exponential of calcium plus 2 and 2 exponential of phosphate negative 3. So solubility product is defined as the product of the ions whichever generated, right? So we are taking the product of the individual solubilities of the ions whichever formed under aquated conditions, which is said to be it's a solubility product. The equilibrium constant for the dissolution of sparingly soluble salt, because the reaction indicated with the reversibility, backward, forward, both are possible spontaneously. So the sparingly soluble salt was taken calcium phosphate. Because of the concentration of pure solid, calcium phosphate is constant. It does not appear explicitly in the equilibrium constant expression. Equilibrium constant for the dilution of calcium phosphate is indicated. K is the equilibrium constant, product concentration by reactant concentration. Here the products are cation and anion, and the reactant will be calcium phosphate. If this is the case, we can go with, so whatever denominator is there, let's take the left hand side, it will become a numerator value. Calcium phosphate into K is equal to, that is called the concentration of calcium phosphate multiplied with the ionization constant, that is called the KSP value. KSP denotes equilibrium solubility product. KSP is called the solubility product. That is equal to product of cation and product of anion, right? So if this is the condition, let me apply calcium phosphate ionization giving 3 moles of calcium plus 2 moles of phosphate negative 3 will be generated. So just now we saw Ca plus 2 with the 3 exponential 3 power, and PO4 negative 3 with the 2 power. That is the case indicated with the 3x for calcium and 2x for phosphate. So here 3x can be taken power 3. Just now we saw here power 3 will be there, and 2x to the power 2. Just now we saw whatever ions are there, phosphate, that indicated with the power 2, that we can put over. So 3x to the power 3 and 2x to the power 2 was taken. When you go with the calculation of entire thing, 3 can be multiplied 3 times, 3 into 3 into 3 if you go with, and 2 into 2 if you go with, the entire numerical product will become 108, and x base x's are same. So that x to the power 3, x to the into x to the power 2. So that 3 plus 2, it will become 5. X denotes what? Solubility. Either you can write it as a x or as s as well. So that 108 s to the power 5 is the right answer, which is mentioned in the option number 1. For question 5, option 1 is the right answer. Let's go with the last question of the session, question number 6. What is the approximate volume in milliliters of 10 volume of H2O2 called hydrogen peroxide solution that will react completely with 1 liter of 0.02 molar KMnO4 solution under acidic conditions? This is the question purely related with the volumetric analysis. ఆమ్లయానకంలో 1 లీటర్ 0.02 మోలార్ KMnO4 పొటాషియం పర్మాంగనేట్ ద్రావణంతో పూర్తిగా చర్యనందు 10 వాల్యూమ్ హైడ్రోజన్ పెరాక్సైడ్ ద్రావణపు ఘన పరిమాణం మిల్లీలీటర్లలో సుమారుగా. Okay, so for this question, we have to go for the calculation with respect to the volumetric analysis. Let me put the balanced stoichiometric equation where 2 moles of KMnO4 can be added with the 5 moles of H2O2, 3 moles of sulfuric acid. So we will achieve, so hydrogen peroxide is liberating oxygen gas over there, and whatever KMnO4 is there, that is reduced into manganese sulfate, and in either product is also generated, which is potassium sulfate. And along with that, we will obtain 8 moles of water. This is the balanced stoichiometric equation. So in this, the relation is, what is the ratio, molar ratio of potassium permanganate with respect to the hydrogen peroxide, H2O2. So how many 2 moles of KMnO4 is reacted with 5 moles of H2O2, that is hydrogen peroxide. At that condition, 5 moles of oxygen will be generated. This is applicable at standard temperature and pressure conditions called STP. According to the above relation, we have to go with 34 grams of H2O2. 34 grams of H2O2 is taken. So oxygen atomic weight is taken as 16. 16 twice. So 32 will be there. 32 added with 2. So that 34. 34 will be the molecular weight of H2O2. At that condition, 34 grams of H2O2 if taken. 34 grams of H2O2 if taken, 11.2 liters of oxygen will be generated at STP conditions according to this equation, right? But here the coefficient for H2O2 will be taken as 5 moles, right? Let me multiply 34 with 5 moles. So that 170 grams of hydrogen peroxide. Then how many oxygen will be generated? 11.2 multiplied with 170 divided with 34, right? So this is the way we can go for this calculation of oxygen liberated. So after the calculation, it will become 56 liters. Okay, so 34 into 5, that means 170 grams of H2O2 is liberating how much? 56 liters of oxygen at STP. Only 34 grams are liberating 11.2, but 170 grams are liberating 56 liters of oxygen at standard temperature and pressure conditions. Here, 1 liter of H2O2 is giving 10 liters of oxygen, that is given within the data. 1 liter of 10 volumes of H2O2 is giving 1 liter of oxygen, right? So that 1 liter of H2O2 is giving rise to the 10 liters of oxygen at STP conditions, right? This is the relation. Then 1 ml of H2O2 is giving 10 ml. So liters can be converted into milliliter form. 1 liter to 10 liters, then 1 ml to 10 ml. Okay, this is the case. But here the oxygen evolved will be 56 liters, right? 56 milliliters. Then 56 ml of H2O2 will give 560 ml of oxygen, right? 56 ml of H2O2 is giving rise to 560 ml of oxygen. Then in order to liberate this extent, the required quantity of hydrogen peroxide will be 56 ml. That 56 ml will be the right answer provided in the option number 1. Okay. What is the approximate volume of H2O2 they are asking for? That H2O2 will be 56.05 milliliters. That will react completely with 1 liter of 0.02 molar KMnO4 solution under acidic conditions. This is the way volumetric analysis based problem got solved. So in order to solve this one, we gone through the mole concept. Later on, mole concept converted into the volume based on that volume of based on the volume generated in H2O2. We further put the relation between H2O2 and the oxygen liberation. Based on that, final volume consumed for H2O2 is given, that is 56 ml. This is the way the entire concept got covered, and even theoretical part, applicable part, and problematic part, analytical part, so many segments of the chemistry got taken into the consideration. And the session is really informative and most important, I can say. Hence, I am sincerely requesting all the viewers to like the channel. In order to comment, we have the question for the session. Here, the question for the session will be, in case of boric acid, we gone through the boric acid, right? Can you mention at least 2 applications of the boric acid in either daily life or industrial applications, wherever you can put on? So any 2 applications pertaining boric acid as the chemical component that can be taken, that can be mentioned in the comment box for the session, and share with the aspirants who are serious about the examination, and subscribe the channel so that we will come up with new content in the near future. Thank you one and all for your consistent listening. Thank you.